All right, talking about dilations. Dilations are whenever you have a pre-image and you're either making it bigger or you're making it smaller. The way you can do that is by using a scale factor. Scale factor is going to be two words. Scale is making something a different size, making it larger, making it smaller, all by the same dimension. So it looks like the same thing, it's just bigger or smaller. And then using a factor, the thing that you multiply numbers by, and like 2 times 3 is 6, 2 and 3 are factors. 6 is going to be a product. So anytime that you hear the word factor in math class, it means you're multiplying by something. So there's just two real basic things that are going on here. First, we need to identify the pre-image and then what's happening with the image. Is it getting bigger or is it getting smaller? That pretty much takes care of everything that you need to be able to do, and I'm going to show you how. So if we had the points right here, and then we wanted to use a scale factor of 2. A scale factor of 2 is going to make something twice the size. It's going to have an area of 4 times the size of the original figure because we're changing 2 dimensions and making them twice as long. So if you make one side twice as long, you make the other side twice as long, it's going to be a figure that's 4 times the size. So whenever we do this, this is a very simple thing to do. Scale factor is 2. With a scale factor of 2, all you do is take all of your coordinates and multiply them by 2. If we had a scale factor of 1/2, you'd find half of all the coordinates. If we had a scale factor of 900, you'd find 900 times whatever the original coordinates were. So -1 times 2 is -2 and then 4. So -2, 4. Label it A prime. That way we are notating what the image looks like from the pre-image. We can see that it's getting bigger and that matches with our scale factor, and that's coming up soon. Then 2, 4. Mm, 2, -2, and then -2, -2. Okay, so you're sitting there going, well, I can't really tell if that's 2 times the size. Whenever it's a very straightforward shape like that, you can just look at one side of it and find its corresponding side. For example, D to C and D prime to C prime. D to C is 2 units, D prime to C prime is 4 units. That's twice the size. That's fantastic. If you look from B to C, that's 3 units. If you check from B prime to C prime, that's 1, 2, 3, 4, 5, 6. That's double. That's wonderful. So if you wanted to find the area of the original figure, A, B, C, D, you just do length times width. 2 times 3 is 6 square units. Then we would do 4 by 6, and that's 24. And that is 4 times the size. And that coincides with squaring the scale factor as it relates to area because we're changing 2 dimensions. Anyway, here is the way to check in every sense of the way. So like if you were given all of your primes and you had to find the original, all you had to do is work backwards, okay? If you're given all of the originals and you had to work forward, all you do is go that way and use your scale factor. So all you do is start with the number that you were given. So we're talking about a figure getting bigger, right? So if we did -2 divided by -1, that would give us an answer of 2. So if we're dividing it, okay, that'd be 2. If we were going from -1 to -2, that'd be multiplying by 2. Regardless, you can see that this is where our scale factor is, 2. That is the hardest part to this. If for some reason you're working backwards and you're sitting there going like, hold on, I got a scale factor of 1/2. All you have to do is ask yourself, did the shape get half the size or did it grow? And if it's shrinking, then it matches 1/2. If it's growing, then it's not matching 1/2. That's how you know it's going to be the inverse of it. So if you had 1/2 and you flipped it, you'd have 2 over 1, which gives you a scale factor of 2. So regardless of if you make a mistake or not, that's your check. Is the figure getting bigger or is it getting smaller? If it's getting bigger, you know your scale factor is going to be larger than 1. If it's getting smaller, you know your scale factor is going to be smaller than 1. All right, that's about it.